Hello everyone, welcome back. And today we're doing this question called Power XN, which is a medium rated question. And effectively it is just a simple one-liner, which is find the power of x to the power of n. And I tried it earlier, like I tried writing return uh x, the inbuilt power function in Python. Like I tried using that and kind of passes the test cases. But obviously, they don't expect this to be the answer for the medium rated question. They expect us to dive a bit deeper to think about it, which is why I think there's a lot more dislikes for this question as well. But, anyways, there's many ways to approach this question, but I'm going to approach it in a recursive manner because I think it looks quite elegant and I liked how it worked out. But let's look at the few different test cases to analyze it. The straightforward one is this, which is 2 to the power of 10, which is, this is our main trick that we will be employing in our case. There's the brute force method, which is 2 times 2 times 2 times 2. We just keep multiplying twos after twos, like 10 times. And that will give us the answer as well. But another way to get this answer is also, we can see that these two are, like there will be 5 pairs of 4s. 4 times 4 times 4 times 4 times 4. So this is another combination. 5 4s will also give us the same result, because if we can just group them, something like that. So when we see a 5, like over here it's an even number, so we had the pairs that we wanted. Over here it's an odd number, so maybe we just like take out one of the 4s, like just put 4 outside this combination. It'll be 4 times 4 times 4 times 4. We just clump these two together and leave the last one out. That way, we have 4 of this and 1 of this. And these 4 can then be clumped further like this. It'll be 16 times 16 times 4. And once again, we can clump this together and it'll be, I think, 196 times 4. And this in return will give us the final value of this. So how do we get here? If we have n is equal to n is an even number, we divide it by 2 and square this by itself. Like we just multiply it by itself. Multiply this by itself. If it's odd number, we take itself and bring it outside, and then we multiply, and then we clump the rest in a similar way. So this is our recursive loop for most of the cases that we will be seeing. But there's also some other corner cases that we have to account for. So this will operate in a similar way. We will first extract itself out, like 2.1, put it outside, and then handle the rest. Then n will be 2. Which is an overkill for 3, but you get the idea. If it's odd number, we just bring the 2.1 outside first, and then deal with the rest separately. So 2.1 to the power times 2.1 as one clump, and then multiply by 2.1 as separately like this, something like this. And we'll get this answer. But basically, these two, same logic, nothing is different. Here's where it gets slightly interesting. A negative value. A negative value is nothing to be worried about, because 2 to the power negative 2, just bring the negative inside, it becomes half, and half to the power of 2 is just 1/4. So once the negative is inside, it behaves the same way as whatever logic that we had previously. So with that being said, let's get straight to coding it out, because the logic that we are trying to get to is, eventually we want to reduce, eventually the value will either go to 0 or 1, like by dividing and subtracting by 1, dividing and subtracting by 1, dividing by 2 or subtracting by 1. We will eventually get to 0 or 1, and we just want to deal with what do we do at that point. So if n is equal to 0, we return 1. It doesn't matter what the x is. We will just return 1. If n is equal to 1, we return x because x to the power of 1 is just itself. Now, the next is where all the logic that we were talking about comes in. So if it's negative, what do I want to do? I want to bring the negative sign inside. Okay. I want to bring the negative sign inside. So I'll return self. This is where the recursive element comes in. Self dot my path. So first things first, I need to divide it by itself, like 1 divided by itself. And then n should be positive. Like if it was negative previously, it should be positive. So I'm going to use absolute over here just to be sure that it's not negative anymore, but you can use anything else. You can use negative n as well. That'll work. So that is if n is lesser than 0. And the next case, which is n divisible by 2, we return self dot my power x by itself, like x multiplied by x and n divided by 2. Because when x multiplies by itself, it halves the number of values that we can see. We package it like that. So 2 times 2 becomes 4, and 4 times 5 is what gives us 10 to the power of, so 2 to the power of 10. So that's just math. And if it's not that, if that means if it is an odd number, we have to bring it outside, like bring x outside. And because we don't want this to be compounding inside within itself and it recurses back and again. So self dot my power x, we just leave it as it is, we just minus 1. Like we have already accounted for the x by putting it outside. So this works over here as well. Like when we bring it out, we just bring the 4 out. We don't bring 2 out or something. So when we bring 4 out, 5 is the one that gets effective. And 4 out doesn't affect 10, basically. Yeah. Like you get the idea, right? Like it's sorry if I'm over explaining things. Like 10 is 2 to the power of 10. 4 to the power of 5 is the value. So if I bring 1 4 out, 5 will become 4. And that's what's happening over here. So when we run this now, it should give us the answer already if I haven't made any mistakes. So let's submit this. And yep, it is doing wonderfully. As we can see, the runtime is 69.23 and the memory is 96.77. I think take the memory with a pinch of salt because depending on the different servers they use, I mean, every time we run, maybe an extra space that I put somewhere or something will affect this and it will cause the percentage to be drastically different. Same with this. If the servers are juiced up one day, it'll be fast and sometimes it'll be slow. But overall, it's a rough gauge for us to understand. Anyways, that is my solution for power x to the xn. And this, in terms of time complexity, could be at the best case log n, like when we just have something perfectly lined up for us, like 2 to the power of 8 or something. Or it could be at worst case n itself. So yeah, that is my solution and hope you guys enjoyed it. Let me know what you think and I'll see you guys in the next video. Bye.